Chemistry, we're moving on to lesson 5 in the reactions unit, and this deals with two-step stoichiometry problems. So we're going to go just straight into a problem. This is just one problem for this lesson. How many moles of CH4 are required to form 3.2 grams of water, H2O? So again, look at the graphic organizer. I want you to get used to using this. Up at the top, picture some little children. That represents you. That represents us. That's our world. We can measure things on a scale in grams. Down inside the blue dashed line is the chemical world. It's counting numbers of particles, numbers of molecules, numbers of moles, relationships, ratios of moles. And we can't count these molecules or moles. There's just too many of them, and they're too small. So what we have to do is rely on our ability to measure things in grams, and then use a translator, the molar mass conversion, that relates the moles of a substance to the number of grams. So if we know the number of grams, two things we need to know: the exact mass in grams, which is something we can weigh on a scale, and exactly what the substance is. It has to be a pure substance. It can't be mixed with other substances. So if we know those two things, the mass and what the substance is, we can convert into a number of moles. And that's the language that the chemical equation speaks. The chemical equation is the only thing that gives us a relationship between all these substances, all these compounds in this particular reaction. So for every 1 mole of CH4 that we put into the reaction, we need 2 moles of oxygen, O2. And what we're going to get out is 1 mole of CO2, carbon dioxide, and 2 moles of water. Or a better way to think of it is that if we want this reaction to run, we need twice as many moles of O2 as we have moles of CH4. So if we have 10 moles of CH4, we need 20 moles of O2. 50 moles of CH4, we need 100 moles of O2, and so on. It's a relationship of how many moles of each substance you need, and what we're going to get out if we put in 1 mole, however many moles of CH4 we put in, we're going to get out that same number of moles of CO2 because they both have coefficients of 1. However many moles of CH4 and O2 we put in, we're going to get out the same number of moles of H2O, water, as we put in moles of O2 because they both have coefficients of 2 in front of them. Also, we'll get out twice as much water as CO2 because H2O has a coefficient of 2 in front of it and CO2 of 1. In other words, it's a relationship of how much of each of these you're going to get out. But again, we don't think in terms of the world of moles. So once we get the number of moles that we need to put in or that we want to get out, then we use the molar mass translator to get back out to the number of grams of that substance that we have. So these are going to be two-step problems, and you'll see what I mean as we do this particular problem. So how many moles of CH4 are required to form 3.2 grams of H2O? So first, we're up in our world. You see the scale appeared up over there in the upper right hand. And that's what we know. We know that we're starting with some number of grams of H2O because we measured it on a scale. And it's 3.2 grams. So we're going to go ahead and put that in the box over there. It's in the grams row. That's our world. And it's above H2O. Now what we're trying to find is moles of CH4. So we're going to put a question mark down there in the lower left. It's in the moles row. That's the chemical world. That's in moles. And it's above CH4. So we need to find a path to go from 3.2 to CH4. Well, the way you need to do this is you need to go down into the chemical equation because that's where we know our relationship between H2O and CH4. There's 1 mole of CH4 for every we're going to get 2 moles of H2O for every 1 mole of CH4. There's no other way we can get over across from H2O to CH4. We have to go into the chemical equation and then across. So let's see that path right here. So we go down, we start with our 3.2 grams. We use the molar mass conversion to get us into the number of moles of H2O. So that's going to put us down in that box where the arrow is pointing, the moles of H2O. Once we're there, only inside the chemical equation can you move sideways, horizontally. from side to side. It's only down there that you can do that. And so we're going to move from moles of H2O down there where that red box just appeared, across to moles of CH4, and that will give us our final answer. So you see up above, we've started to write an equation. We start over on the left with 3.2 grams of H2O. We end over there on the right with some number of moles of CH4. Now, the chemical process here, the chemical reaction, moves from left to right. It moves from CH4 as a reactant and O2 over to CO2 and H2O as products. But the math equation moves in the other direction. In a math equation, you always go from what you know, what you're given on the left, that's the 3.2 grams of H2O, over to what you're trying to find on the right in the math equation. Okay, so the two, don't get the two confused. So what we need to do is we need two conversions, as you can see. You go down into the chemical equation through the molar mass, and then you go across from the moles to moles relationship between H2O and CH4. We skip over O2 and CO2. We don't care about them. They're not a part of this problem. So let's go ahead and build this equation. So we start off with two boxes because it's going to take two steps to do this problem. And the first relationship is the molar mass of water. 1 mole of H2O equals 18.02 grams of H2O. So remember, that is called an equivalency. Now we need to form two conversion factors from the equivalency. So there's the first one. You simply put one of the equivalencies over the other. So it's 18.02 grams of H2O over 1 mole of H2O. Or you take the other one, the other way around. It's 1 mole of H2O over 18.02 grams of H2O. Those are both true statements. Those two conversion factors are both true. But only one of them is going to help us in the problem. So which one should you put in that box up above in order to proceed through this chemical equation here? And the answer is you put this one. Why? If you're not sure, if you don't see why. Let's put it up there. Now you see you have 3.2 grams of H2O. That's in the numerator of a fraction. Even though it looks like there's no fraction there, it's just one level, it is in the numerator. If there's only one level, it's the numerator. It's on the top. So you have grams of H2O on the top, and you look what you just put in the box there, you have grams of H2O on the bottom. You can cancel units of measure just like you cancel variables in math class or numbers in math class, and you can cancel across a time sign. You cannot cancel across a across a division sign, across an addition or subtraction signs, only across a time sign, a multiplication sign. So we're going to go ahead and do that. So we're going to cancel grams of H2O and grams of H2O. This is why it's important to write both the unit of measure and the substance. It has to be the same unit of measure and the same substance. You don't want to cancel grams of CH4 or CO2 or anything else. You don't want to cancel moles of H2O here. You want to cancel grams of H2O with grams of H2O. Again, and notice you're only canceling the units of measure. You're not doing anything with the numbers at this point. Okay, so there we go. So now what would happen if we solved this equation at this point? Normally we won't. But let's say we solve 3.2 times 1, that's what's on the top in that box, divided by 18.02. We would then get the number of moles of water. So we're going to go ahead and do that. And you see that that appears in the box down on the lower right. We get 0.18 moles of water. Now we don't normally solve, in fact we don't ever do it beyond just this example. We don't solve for these intermediate parts of the equation. We don't care about 0.18 moles of water, but I'm just showing you where this equation is taking you right now. It's giving you moles of H2O. And you see that the only unit that hasn't been canceled out so far in the box up there on the top is moles of H2O. So that's what you have, but we don't care about that. We want to move over and get moles of CH4. That's what the problem is asking us for. So now what's our next equivalency to get us from moles of H2O to moles of CH4? Well, it comes straight from the equation down there, the chemical equation. There's 1 mole of CH4 equals 2 moles of H2O. You simply take it straight out of the chemical equation. You have 1 CH4 down there on the bottom. You have 2 H2O, you simply insert the word moles in there. 1 mole CH4 equals 2 moles of H2O. That's the relationship that we know between moles of H2O and moles of CH4. So there's the equivalency up there. 1 mole CH4 equals 2 moles H2O. So now you're going to create 2 conversion factors. There's 2 moles of H2O for every 1 mole of CH4. Or there's 1 mole of CH4 for every 2 moles of H2O. Those are both true statements. See if you can figure out which one is going to go in the box up above. And the answer is this one. So let's put it up there if you're not sure why and see why. If you put that up there, two reasons why you know that's the correct conversion factor to put in that box. One of them is this. Moles of H2O up there in that first box up on the top cancels with moles of H2O down on the bottom. One's on the bottom, one's on the top. So they cancel out. The other reason you know is that the only unit of measure you now have left, moles of CH4, that's what you want your final answer to be. I call that the last man standing. That's the only unit of measure that hasn't been canceled out, moles of CH4. So now you know that you have your equation set up properly because everything canceled out except the unit that you want in your final answer. Okay, so now we're ready to figure out how many moles of CH4 we have. So we look up in the upper left again, look way up in the upper left of the page, and you see 3.2. You multiply everything on top, divide by everything on bottom. So 3.2 times 1 times 1, and now you divide by everything on the bottom. Divided by 18.02, divided by 2. And when you multiply all that out and you round to 2 significant figures, you get, actually it's 1 significant figure here, it's 0.09 moles of CH4. That's your answer. And while you won't normally do this on your assignments, we'll go ahead and put that down there. That'll replace the question mark down there on the bottom left. So we'll go ahead and put it down there. And that is our answer. So notice what you have. The chemical equation tells you that you're going to get twice as many moles of H2O, 2 H2O, for every 1 mole of CH4. Twice as much water as you put in methane. And you'll notice that that's what we have there. We have 0.09 moles of methane, and we have twice as many moles of H2O, which is 0.18. But our final answer that we're interested in is 0.09 moles of CH4. So that's how you do these problems. You allow the units of measure to set the problem up for you. And that's a process you need to get used to doing. It's a little tricky at first. It seems a little unnatural at first, but soon it will seem natural. And you'll find out that is the only way to solve many chemistry problems, is to get your units of measure to line up so that you end up with the units of measure for the final answer that you're looking for, and make everything else cancel out. All right, that takes care of this lesson number 4, and we'll move on to lesson 5 in the next video.